Okay, so hopefully we won't spend half the entire period doing this, but 3 marks each for these expansion questions, okay? You can choose. I showed you 3 methods. You can pick either of any of the 3, okay? In terms of the quickness, I always just choose to do this, right? Okay. First one's x squared minus 3x plus 2x minus 6. Now, you will lose marks if you leave it at that today. I was a little bit lenient because I just said expand with this. This is, again, just to re-illustrate the reason why we do formatives is both for you and I. So if I write a question, you guys don't do what I'm looking for, then I'm more specific with the question when I ask it on the test. So on the test today, it's expand and simplify. Okay, so you cannot leave it like this. You need to collect the 2 terms in the middle, and that's it. So it's going to turn into x squared minus x minus 6. Okay? Same thing on the next one. There's a whole bunch of these on the test today, so a whole bunch of factoring, a whole bunch of these. So there's some free marks up for grabs, I think, with the expansion. Okay? 2x times 5x is going to be 10x squared. 2x minus 2x, sorry, plus 15x minus 3. Okay, so 10x squared. You just collect the 2 in the middle. Negative 2 plus 15 would be plus 13x minus 3. Okay? Factor each of these by finding the greatest common factor, right? Okay, well, when you see find greatest common factor, I'm not going to explicitly ask you this on the test today, but you can see greatest common factor questions when there's kind of 3 terms, or there's sometimes 2. You know what I mean? And even in the trinomials, you can see it in the trinomial sometimes too, right? On the other quiz. If you can like pull out something that's common across all of them, then take it out. That's what finding the greatest common factor is. And so if you write, I showed you guys, we did a whole bunch in class where we found the greatest common factor. Like in this particular question, it was 3, right? Yeah. Right? And then you guys have to tell me, you have to write the 3 out front. It just doesn't disappear. You can't just make things disappear in math. You just like, you can, but there has to be some reasoning behind it. Yeah, Retta? It is 3x, sorry. Yeah, I was getting a little ahead of myself. So some of you did that as well. Remember, when you're dealing with these things, you're always looking at the numbers and the variables. I see that I can take out an x as well. So I'm going to do that. And then I'm going to write what's left after I remove the 3x from each of those. So it's going to be x minus 4. I know I'm right because if I were to expand this back into both of them, I would get this back. Okay, it's like a little mental check. Okay, so the next one just a little bit harder. It's the exact same idea though. I'm looking at all 3 of these terms and I'm deciding what's the biggest thing I can take from all of them. So you just start building your greatest common factor off to the side. So let's deal with the numbers first. With the numbers, 45, 5, and 25, I think I can take a 5 out. Right? That's the biggest thing I'm going to take from the numbers. Okay, so great. What's the next thing? Well, I've also got m's in here. Right? Okay, well, I'm going to take an m because it's in all 3. How many is determined by the smallest number I can see on them? M cubed. Okay, now I have one more. I have another variable in here. I see n's. Okay, well, I know I'm going to take an n. How many is determined by the fact that there is only 1 in the second term. Right, so I'm going to take out an n, just 1. So then it just doesn't disappear. 5m cubed n Tell me what's left after you do that. So by that I mean, if I were to move this down, and some of you might need to do this, I don't know. You're writing what's left after you divide each of these by 5m cubed n. Right, that's what goes inside the brackets. So 45 divided by 5 is 9. 3m's cancel with the 3m's in the top. 1n cancels with an n, so 9n. Right? Minus 5 cancels with the 5. 3m's cancel with 3 of the m's up top. That's going to leave you with m cubed. And 1n cancels with an n. In the last one, 25 divided by 5, it's going to be positive 5, so those wipe out. M cubed, 3m's cancel with 3 of the m's in the top, you're left with 1m. 1n cancels with 1n in the top, you're left with 3. That's it. So a little bit of a... It takes a little bit more time to do that, but you're ensuring that you're going to get it right because you're doing each term individually. Okay, you're not going to miss anything that way. It takes a little more time, but a little more accurate. Okay. Same idea down here. This whole page kind of stems from your ability to find the greatest common factor, right? Except with the grouping, you break the we'll call it the polynomial because there's 4 of them, 4 terms. We're going to break it in the middle. I see in the first 2 that I can take out a 3p. Right? You're going to write what's left, p minus 4. In the second one, you could take out a plus 10. Is that it though? No, you can take out a q too, right? Because there's a q in both of them. So now you tell me what's left. Well, it's going to be p minus 4. Now I still have 2 halves here, and on either half, I see that there's a p minus 4. So across both halves, I can take the p minus 4 out. Right? And then what's left after I remove them? 3p plus 10q. That's it. That's factoring by grouping. That's it. Okay. Same thing here. Break it down the middle. What's common and what's the biggest thing I can take out of the first 2? X squared. What's left after I do it? X plus 1. Look at the second half. What's the biggest thing I take out of there? Plus 2. What's left after I do it? X plus 1. Always, if you've done these correctly, should see the same piece spit itself out on both sides. So then you just remove it again. Done. Any major issues? Okay. Does anybody need to copy that or okay? Okay, so with this question, here's what I'm interested in. I suppose some of the challenge is in the way that you set up the question, okay? And had you have asked me about this because I assigned it, it would have gone better. But it appears that nobody did it, which is why I put it on there, because I knew nobody was going to do it, and I wanted to address your attention to it before the test. So you're interested in the shaded area, right? So you got to come up with an algebraic expression, just one, that represents the area of that shaded, or the area of the shaded area. Maybe that makes sense. Okay. So, just in theory, just as I'm looking at that, okay, I need to figure out the area of the outside. Okay, so I'll do all the work in blue for the outside. If you can you see the blue okay? The projector's always not too great, I don't know. Okay, I'm going to do all the work for the blue, and then in red, I'm going to have the area of the pool. Okay. So the area, I'll write this statement in black. Area of the shaded part is equal to the area outside minus the area inside, or the pool. So we kind of have an understanding of what the attack angle is now. Okay? This, you're going to do a bunch of work here, and you're going to do a bunch of work here. You're going to subtract the two polynomials, and you're going to get one algebraic expression that represents the shaded area. Do we have any like major concerns with what we're doing right now before we do it? Okay? That's the attack angle. Okay, you're just taking the outside area, and then you're basically like deleting the inside area, right, to find that shaded area. That's what's happening. So you're subtracting it off. Okay? So that's some of the thinking done, not all of it, but some of it. Okay? You may or may not have an issue with this next part. So we're going to have to do, let's do the outside first, okay? So, what's the area of any rectangle? Okay? Remember, I'm doing this in blue on purpose, right? So all the stuff I'm doing in blue is for the outside. Okay? You can denote this how you choose on the test. If you say area outside equals whatever, right? But what is the length? The length of the outside edge. So I'm specifically looking at this. How do I figure that out? I heard somebody say it. So the length is going to be 2x minus 1. Is that it?
No.
What else do I have to add? Plus 7 plus 7. Right? That adds these two pieces to the end. So you have your 2x plus 7. That only takes you from here to here, though. Then you got to add the other two 7s. Okay? So then you get, for the length, you get a 2x minus 1 plus 14, which is going to be 2x plus 13 for the length. Okay? And then you're just making a nice, neat list of everything. Okay? So then we're going to jump over and do the width. How do we do the width? The same way. Except we're just looking up and down this time instead of left to right. Okay, so how do I do that? What's the width equal to in the picture? 12 plus, that only takes me to here and here. I got to add these two x pieces. Plus x plus x. So my width is going to be 12 plus 2x. What are we after? The area. Okay. How do I get the area? It's telling me to multiply length times width. So area outside is equal to 2x plus 13 multiplied against 2x plus 12. From there, this is a pretty loaded question. This is why it's worth, what did I put on here? Oh, I didn't. Okay, it's probably 10 marks. It's a loaded question. Oh, was it? Okay, so I asked you, okay. It's a loaded question is the point. Okay, there's a lot going on here. But the more organized you are and systematic, the easier it becomes all of a sudden, right? Okay, so all you're going to do here is expand and collect like terms. 2x times 2x. This is what I mean. You guys have the skill to do this. There's just a little bit of thinking now. Right? 2x times 2x is 4x squared plus 24x plus 26x. What's 13 times 12? 156, okay? Collect the two terms in the middle, and then you're done with this part of the question. Yes? Are you okay? Oh, sorry, I couldn't even see who's talking. Yeah.
I was just remarking on how done it is right now.
How, what is?
Done. It's done. This is.
What is going on? We're not done yet. We're only halfway. Don't forget what we said. What did we just figure out? We figured out the blue piece, right? I still have to figure out the second piece is easier. The area of the pool is much easier than the area of the outside, right? Area of the red rectangle in the picture is just length times width. Okay? So there's none of this funny having to add extra pieces or anything, right? Area of the pool is length times width. In our picture, the length is 2x minus 1. And the width is just 12. So then you expand it, and that's it. You're just putting the 12 in, right? 24x minus 12. So you now have the blue piece and the red piece that we were after. The area, or the expression that represents the shaded part, is just the blue piece minus the red piece. So that's all you're going to do. It's the pool deck, right? Is going to equal 4x squared, the blue piece, plus 50x, plus 156. I'm going to move this over, sorry, I don't have much room. I'll do it down here. I wasn't really conservative with space. Okay, that's the blue piece. Then you're subtracting the red piece, 24x minus 12. Now, I would put that in brackets for a reason I'll show you in a second. Because it's minus and you have a negative sign over here, you have to do minus a negative. So what did I say to get rid of the brackets? Always expand into it. So your next line here okay. So what's your final answer? You're just going to collect like terms. I see a 50x and the 24x. I can collect those. And then I see 156 and 12. Collect those. And that's your final answer. 4x squared. 50x minus 24 is going to be positive 26x. 156 plus 12 is 168. That's it.